All right, so as I look at this, I notice that I got to prove side angle side. So the one thing I notice off the bat, they tell us a couple of things. Just by looking at the image alone, I know that because of this hash mark and this hash mark, that line segment AD is congruent to line segment CD. Okay? So I know that. They also tell us that, and I can see this by the image too, that this angle is 90 degrees. But the way that they word it here is they say that BD is perpendicular to AC. Well, that will let me know one thing, that this angle is also 90 degrees. Why? Because it's a linear pair. So right now I'm just thinking, what's my game plan? How am I going to write this proof? And I'm just going through. So I have a side, a pair of sides that are congruent. I have a pair of angles that are congruent. Now I have to choose. I have two remaining sides. I have this side and I have this side. So in other words, do I prove that AB is congruent to BC? And then I have this side here, which is BD. Both triangles share BD. Well, if that's the case, then that would be my side. Also, it has to be that side. Why? It has to be that side because this is the angle trapped between this side and this side. This is the angle trapped between this side and this side. So now I got to formulate that and write it in a formal way. So the first thing I'm going to do is I'm just going to list what's given to me. I'm going to list that BD, line segment BD is perpendicular to AC, and AD is congruent to CD. That was given to me. Okay? That was given to me. All right. Now here's the other interesting thing. I know what the answer is supposed to be. I'm supposed to prove that triangle ABD is congruent to CBD. And I know that I'm supposed to prove it using the side angle side theorem. So now I just got to fill in the blank spots. Okay. Well, I know that angle ADB is congruent to CDB. And that is because they are a linear pair / right angles. So because they're right angles, in other words, the BD is perpendicular to AC, then I know the two angles, because they are a linear pair, that both angles are perpendicular. Or in other words, they're both equal to 90 degrees. So now I've got my two angles, right? So I've got one side proven. So let's think of it in terms like this. Side, as I'm writing the proof. My first side is going to be AC is congruent, or not AC, AD is congruent to CD. That was given. Then I just proved my angles. Angle ADB is congruent to angle CDB. Now the last thing I need to do is prove the side. And I know it has to be BD is equal to BD. Well, duh. So let's write that down here. The line segment BD is congruent to the line segment BD. Does anybody remember what property that is, though? And I'll give you a clue. When you look in the mirror and you see yourself, what do we call that? Reflection. So what type of property is it? Reflexive. So because this is a reflexive property, I'm pretty much done, right? I've proven a side and the angle trapped between the other side. So I've got my side angle side, so based on that alone, I can say that ABD is congruent to CBD based on the side angle side theorem. Now sometimes, it's funny, each textbook that I've taught out of, sometimes they call it a postulate, sometimes they call it a theorem, so I'm not going to get real formal on that. Sometimes the books don't even call them by their names. They say this is theorem 1 and theorem 2. I'm more concerned with the logic and the flow and how you present your argument, okay? So if you accidentally write postulate or you don't write theorem, I'm okay with that. When you go to college, if you're going to be a mathematician, you'll definitely need to be a little more formal than Mr. Adams is. Are there any questions? Thumbs up if you get it, thumbs down if you're completely lost. Where are you guys at? Okay.